Okay, kids, so we're going to have to kind of wing this a little bit. So I'm trying to hold my iPad and film this all at the same time. So we're starting with magnets, and kind of a dramatic way to show the strength of a magnet is that up here on the mantle, I've got one of those really, really strong magnets. And then down below here, I've got, if you'll notice, if we pan down, it's a piece of string that goes tied to a block of wood. And that is tied to a paper clip that's up here. And so that paper clip has such an attractive force towards this magnet through the wood down here, and it's strong enough to keep that magnet suspended so that it appears to float in midair. Now, go down like this, okay? So this will make sense later on. I'll kind of jump ahead because I kind of need to show you this while I'm here. So when you have an electric current, so pretend that there is an electric current going through this string, okay? So to figure out the direction of the magnetic field, what you do is you point your finger in the direction of the electric current. So let's say that the electric current is going up. So then you wrap your right hand in the direction that the magnetic field is going to go. So if the current is going up, I wrap my hands around like this. So imagine like this is the plane of the paper. So the magnetic field would be coming out of this side, but then it would be going in on this side, okay? So if I wrap my hand like this, I would curl it around like this, so it's going to go like this. Now, if the direction of the current is reversed, and, oh, there we go, and the current is going down towards the bottom of the string, then I would put my hand like this, and then I would curl my fingers in this direction, okay? So I'm going to wrap it around like this, okay? So the magnetic field will be going in on this side and out. Hold on, I lost it. It would be going in on this side and out on this side. So I'm going to put it down like this, wrap my hand around like this. Now, if the current's going up, I wrap my hand like this. It's called the right hand rule. Now, there's going to be much more to this right hand rule. There's going to be more variations. But for now, here's what you're going to do. Find the direction the current is going, and this is the Ben Franklin definition, so we're treating it as like positive charges. So you're going to go up like this, wrap my hand like this. If the current was going down, I would point down, and go around like this. Now, another way that you can show a magnetic field is that underneath this piece of paper, I've got a bar magnet with north and south poles. So I'm going to lay that over it, and then I'm going to take and dump some iron filings over the paper, okay, like this. And what you'll see is that when I tap this a little bit, that these iron filings are lining up with what's called the magnetic field lines, okay? So when you talk about fields, whether it's gravitational fields, electric fields, magnetic fields, this has a very, very distinct line. Now, we'll get into the direction of that later on once I kind of explain what you determine the north and south pole is. Here's a spoiler alert. The North Pole, what we call the North Pole of the Earth, is actually the South Pole, but we'll get more into that later. But what I want you to get out of here is the fact that you have these distinct lines, okay, emanating out from the North Pole and emanating out from the South Pole that go around like this, okay? So it isn't just a continuous field, it exists in distinct lines. Now, another way that you can show that is, and you all have played with this, the famous ferrofluid. Okay, where did it go? Okay. So now, with the ferrofluid, you can, this is another way of showing that that magnetic field exists in distinct lines. If it was a continuum, then you wouldn't have those points. Now, obviously this is a function of distance. So the closer it is, the stronger the magnetic field. The further it is, the weaker the magnetic field. Okay? All right, so the rest of the stuff I'm going to shift over to drawing on the normal stuff. So bye for now.